Hey everyone, and welcome. Today, we're diving into the invisible shield that protects pretty much your entire digital life. Transport Layer Security, or as you probably know it, TLS. It's truly the unsung hero of the internet. But how does it actually keep you safe? Let's find out. So think about it for a second. The last time you bought something online, or maybe sent a private message, did you ever stop and wonder, is this conversation really just between me and the website? Is anyone else listening in? Well, the surprising answer is no, not by default anyway. You see, the internet, at its core, was designed to be open and share information, not to be private. By default, our data is just out there totally exposed, and that's exactly why it needs a digital shield to stay secure.
To really get this, we have to talk about what I like to call the internet's postcard problem. It's a really simple way to think about it.
So an unencrypted internet is basically like sending a postcard, right? Anybody who handles it along its journey, the mail carrier, the post office, can just flip it over and read your message. But the encrypted internet, well, that's like sending a sealed, tamper-proof letter. Only the person it's addressed to can actually open it and see what's inside.
And that right there is where TLS comes in. It is the digital envelope that finally solves the internet's postcard problem for all of us.
Okay, so what is TLS technically? It's a cryptographic protocol. But what does that even mean? Just think of it like a secret rulebook that your web browser and a website both agree to follow. It's a set of rules that makes absolutely sure no one can eavesdrop on your conversation. And to create what we call a secure channel, TLS has to guarantee three absolutely critical things. First, confidentiality. That one's easy. It just keeps your conversation private. Second is integrity. This makes sure that your messages aren't secretly changed along the way. And finally, authentication. This one is huge. It's how you know you're actually talking to your bank's website and not some clever imposter. So how in the world do two computers who've never even met before create a brand new secret code in the blink of an eye? Well, they do it with a process called the TLS handshake. And yeah, it's pretty much exactly what it sounds like. A super fast, super secure, secret handshake.
Okay, let's break it down. It starts with the greeting. Your browser says hi to the server, and they quickly agree on the rules, the specific type of encryption they're going to use. Next up is the ID check. This is so important. The server shows your browser its digital ID. It's called an X509 certificate. It's kind of like showing a driver's license to prove you are who you say you are. And once all that is settled, they do the final step. They create the secret key. They work together to generate a totally unique, one-time use key just for this session. And the craziest part? This all happens in a literal fraction of a second. It's amazing.
But here's the thing about security. It can never stand still. It has to keep moving. TLS is always evolving, always in a constant race to get faster and stronger, and stay one step ahead of new threats. So let's take a quick look at how it's changed. You know, it all started back in the 90s with something called SSL, which honestly had a lot of flaws. Then for more than a decade, TLS version 1.2 was the king. It was the standard we all used for everything. But in 2018, everything changed with TLS 1.3. It was a complete redesign from the ground up, and believe me, it was a real game changer for both speed and security.
So what was the big deal? Well, the number one improvement was speed. The old TLS 1.2 handshake needed two back and forths, two round trips, between your computer and the server. TLS 1.3 slashed that down to just one. Now you might be thinking, what's one round trip? Well, that single change can shave off up to 100 milliseconds of lag. And that's the difference between a website feeling instant and one feeling kind of sluggish.
The other huge upgrade was on the security side. TLS 1.3 made a feature called Perfect Forward Secrecy mandatory. Here's why that's so cool. It means every single time you connect to a website, you get a brand new, temporary, one-time use secret key. So even if a hacker manages to steal a server's main long-term key, it doesn't matter. They still can't go back in time and decrypt your past conversations. All your old data stays locked up and secure. It's a massive win for privacy.
So we have this amazing technology, right? TLS gives us these incredibly fast, incredibly secure connections. But the very thing that makes it so powerful, this ability to create an almost unbreakable shield, actually raises some really big, really complicated questions for all of us.
So you'd think, with encryption this strong, the answer would be a simple yes, right? Our conversations are totally confidential. Well, the reality, as always, is a little bit messier than that.
Here's the catch. While the content of your data, the actual words you type or the video you're watching, is completely hidden, the patterns of that data
can still tell a story. Sophisticated AI can look at the flow of encrypted traffic and start to make some 20 good guesses. They can figure out if you're streaming a movie versus just browsing a website, or they could even identify the specific model of your smartphone, all without ever breaking the encryption itself. Kind of spooky, right?
And this leads us to a really tough question, doesn't it? We all want our privacy. We need it. But what happens when that exact same unbreakable privacy is used to hide illegal activities? Is total unbreakable encryption always a good thing for society as a whole?
You know, there's a quote from our source material that just hits the nail on the head. It points out this long-running debate where, on one hand, encryption is an absolutely essential tool for regular citizens to protect their rights and their privacy. But on the other hand, it can also act as a shield for criminals, which makes it a huge obstacle for law enforcement. Finding that balance? Well, that's one of the great technological and ethical debates of our time, and it's something we're all going to be grappling with for a long, long time to come.